Hello and welcome to another of MATLAB Helper's amazing videos on stock market with MATLAB. So in this video, we are going to look at the code view or the backend of the stock prediction application. Now, if we just go into the code view of the application, we'll find several functions and callbacks and properties that I have defined within the application to design the backend. Now, let me just begin our discussion by looking at the variables or the properties that we'll need throughout the application. So at the beginning, we need a variable to store the historical stock data for a specific company that the user wants to fetch from the Yahoo Finance website. After that, we need a variable called ticker to save the ticker value of the company that the user has chosen from the drop-down menu. Later on, we need two variables, sdate and edate, to store the start and end date during the period of which the user wants to fetch the historical stock data. Now, the sdate or the start date will be calculated from the end date, which I have taken to be the date of the system's current day. So, if the date is 30th of July 2019, then the E date will be equal to 30th of July 2019, and the S date will be 5 years before that. Now we need to make sure that S date and E date are in posits time format or units time format, because that's what the Yahoo Finance website actually understands. Thereafter we have reg. Now reg is the variable that will save the type of regression model that the user has selected from the drop-down menu. After that, we have two values, mdate and mopen, of which mdate is the variable that stores the maximum date value from the dates that we have extracted from the Yahoo Finance website, and mopen contains the maximum opening price of that company's stock value for the 5-year period. We'll need these two variables to compute the normalized date and opening prices, which we will use in the nonlinear regression model later on. After this, we have this variable called model. Now, this variable model is what will save the regression model that we calculate from the data. Thereafter, we have the variable mu or mu. Now, mu is the normalizing coefficient that we find by using the regression in linear as well as in polynomial regression. Now, we'll talk more about this in some other video, and after that, what we have here is the f. Now, f is the nonlinear function that the user chooses. We'll let the user choose the nonlinear function by means of a list dialog box, and we'll also look into that in a few minutes. That's all about the variables that we need in this particular application. Now, out of these applications, which are about 9 to 10 variables, so we could have actually omitted a few of them, and we could have also included a few more depending upon our own personal wishes. So this particular application, as I have told before, is just, you could say, an archetype of applications like this, and you can obviously build on top of this based on your requirements. So after this, we'll move on to the starter function, which is the function or the callback that will be executed when the application first starts. Now, first of all, as we saw in the UI in the previous video, that we had not mentioned any companies here in the drop-down menu. Now, the reason for doing that was because I wanted for you all to write some code in the starter function that will automatically show the companies that we actually worked with in module 2. Now, these companies, as we saw in module 2, could be extracted from the Excel spreadsheet that we used again in module 2. So I wanted that you would do or implement the same code here to display the companies in the drop-down menus. Now, what I have done here is simply choose 4 companies, 4 reference companies, from which the user can choose one. Now, I have saved the company in the variable companies, and then I have displayed them in the drop-down menu. Right after that, what I've done is I've calculated the start and end date and saved them in respective variables sdate and edate. before doing that, I have found the current date of my system, which I have done by using the function datetime and the option now. Then I've converted it to POSIX time and then taken the floor of it. Now I've taken the floor of it because sometimes MATLAB actually gives the POSIX time values in a floating time numeral, and that numeral is something that the Yahoo Finance website will not understand. And that's the reason why I've used this function, so that we get an integer value out of this calculation. After that, I have calculated the starting date by subtracting 5 years from the current date. And I've done that by multiplying the number of seconds in a day with the number of days in a year and 5 years. Alright. Furthermore, I have made the end date equals to the current date, because we are assuming that the end date is in fact the current date. Alright, so that's all we'll be doing in the status function callback. So we'll just be showing the companies in the drop-down menu, and after that we'll just be calculating the starting and end dates. Alright, so after this what we'll do is we'll go to the button group. Alright, so we'll go to the callback section here and then regression button group selection change. Alright, so here as you can see, we are allowing the user to select one of the three options of radio buttons. The first one is C data, the second one is fit data, and the third one is obviously clear access. What we're done here in the callback is whenever the user selects a different radio button, we will fetch that button's value and then we will find that button's text. Well, right now we are using the button's text to run a switch case conditional here, and we are checking the text of the button to run individual programs. Now, first of all, in the C data section of the switch case statement, we'll find that I have included a few lines of code to actually plot the existing historical data. So as you can see, I have plotted onto the stock axis the historical data that we have saved in the variable HisData. Now we are displaying the date of the historical data with the opening price. All right, and we have also chosen a very appropriate title for this, and after that we have just labeled the X and Y axes, and then we have mentioned the legend. All right, this is what we'll be doing in CData. So when the user clicks on CData, the user can see historical date values against the opening prices. All right, so now you all must be wondering how we got the historical data, right? Now we'll come to that in just a minute. Before that, I'll just quickly go through the other cases, and the first of which is fit data. Now whenever the user chooses the fit data radio button box, what will happen is that this function called regression function will be called, and based on the user's selection from the regression drop-down menu, this function will execute one type of regression and will give us a model of that regression. Finally, we have the clear axis here, and this clear axis, when chosen, will simply clear the stock axis in the UI figure. Now let us quickly move on to the function that we'll use to fetch historical data. Now this function is very similar to what we saw in the historical stock data section in module 1. So it's exactly the same function except for a few differences which I will note here. So first of all, what we've done here is we have just simply made the frequency equals to 1 day. Instead of letting the user choose the frequency, we're assuming that we need the daily data for the chosen stock company for a 5-year period. Alright, the rest is the same. And finally, what we have done here is that we have changed the variable's name into which we are saving the tabular historical data to app.hisData. Now HisData will store the tabular historical data that we are interested in. Out of all these columns, the only two we are currently interested in are date and opening price. Next, what we're doing is we are finding out whether there are any zeros in the opening price. Now this might happen due to some error in fetching the paid source from the Yahoo Finance website, and this might cause some serious errors whilst performing regression. So we are just removing the rows that have accidentally fetched 0 in the opening price section. Alright, and finally what we're doing is we are finding the maximum of the date and the maximum of the opening price over here. Alright. Now we have used the function sell to mat here while accessing the opening price, because this opening price is actually a cell array of numbers, and we cannot operate the max function on the cell array. We need to first convert it to a matrix by using the function sell to mat, and we can then use the function max to calculate the maximum in this particular matrix. We'll be using this function sell to mat throughout this application. We could have omitted using multiple sell to mats by simply changing it over here when making the table. Alright, so that's something that we could have done, but I have left it for you all to do. So this is what the historical data function does. It just fetches historical data from the Yahoo Finance website and saves the data in the variable out of its data. Alright, so this is all in this particular video. In the next video, what we'll do is we'll just begin our discussion from how we can code the other drop-down menus and how we can fit the actual regression data onto a regression model and plot the curve for it. Alright, so I hope that you have understood whatever we have discussed in this video, much of which was just a revision of the previous videos we have had. So I hope that you have all understood the things we have discussed, and we'll continue our discussion in the next video. Till then, it's bye from me.